In an earlier video, we talked about how you can only add square roots if they're like terms. So an example is 3 root 2 plus 5 root 2. And what I said was we treat that just like 3x plus 5x. It's exactly the same type situation. 3x plus 5x is 8x. And 3 root 2 plus 5 root 2 is 8 root 2. So we can only add roots if the root part is exactly the same, just like the x and the x. If I ask you to add root 5 and root 10, you can't do that because they're not like terms. It's just like asking you to add x plus y. X plus y is not xy because that's x times y. There's no way to add root 5 and root 10 unless you approximate and use decimals. But sometimes you can add them if one of the roots simplifies and they end up being like terms. And that's what this next example is. So when you look at this question, 2 root 405 plus 9 root 5, it appears that we can't add them because they're not like terms. But 405 does simplify. And I went to the number calculator, the factor calculator on mathisfun.com. I'll put a link in on the calendar and on the WAMAP assignment. But you can go down there and punch in the number 405. These are small, I apologize. And look for perfect squares. Now remember, these numbers up above are the important numbers. They're what allow us to simplify square roots. So I'm looking for 4, 9, 16, 25, 36. I want the biggest one possible that divides into 405. Now if you look down this list, it looks like 81 goes in. Is that the biggest perfect square? Yep, there it is, 81. 81 divides into 405. So we'll take our calculator, go 405 divided by 81, and we see that that's 5. This problem then becomes 2 root and 405 divided by 81 5 times. So that's 81 times 5 plus 9 root 5. And we know that the square root of 81 simplifies. I'm going to go over here. Its square root of 81 is 9. So that 9 goes out front. Remember, there's times right there between the 2 and the root. Square root of 81 is 9. 9 times 2 is 18. So this is 18 root 5 plus 9 root 5. And those are like terms. They both have the same root part. So it's like they're both an x or both a y. 18x plus 9x. That's what you think. Well, 18 and 9 make 27. So this is 27 root 5. I'll do a few more examples right from your assignment right now. Take a look at these questions. These, at least some of them, are a little bit more obvious because the perfect square is hidden in the number. Remember that list on the previous page is the important list. In fact, 64 is a perfect square. That's 64 times 10. 490, 49 is a perfect square. That's 49 times 10. 48, a little bit harder, but at least it's a small number. But again, you can go to that factor calculator, and when you do that, you'll see that 48 is 16 times 3. So here goes. This ends up being 3 root, and that's 64 times 10 plus 5 root 10. The square root of 64 is 8. The 8 goes out front. We're going to multiply. 8 times 3 is 24. 24 root 10 plus 5 root 10. Those are like terms. I can add them now. This ends up being 29 root 10. Next example. This is 5 root, and 490 is 49 times 10. 49 is our perfect square, plus 9 root 10. square root of 49 is 7. So we're going to multiply. 7 times 5 is 35. 35 root 10 plus 9 root 10. 35 and 9 make 44. 44 root 10 then is my answer. Last example. All right, I already mentioned that 48 had a perfect square root of 16. 16 times 3, got 8 out there, plus 12 root 3. Square root of 16 is 4. The 4 goes out front and you multiply. 4 times 8 is 32. 32 root 3 plus 12 root 3. 32 and 12 make 44. So 44 root 3 is my answer.